This curve is right-sided parabola, and this point is the vertex, which is 0, 0. Coordinate of vertex is 0, 0. Now, this point is S, which is called focus, and distance of focus from the vertex is A. So, the coordinate of focus is A, 0. Now, we have a straight line which is at a distance A from vertex. It's called directrix. The distance of this directrix from vertex is A. So this point is x equal to minus A, and x equal to minus A is the equation for this directrix. We can write this equation in standard form, in this form: ax plus by plus c equal to 0. So this equation is now 1 into x plus 0 into y plus a equal to 0. Now, any point on this parabola is denoted by P. The coordinate of P is x, y. Now, for this parabola, we know that the ratio of distance of this point P from the focus to perpendicular distance of this point from the directrix, that is pk, is denoted by E. It is called eccentricity. And for parabola, eccentricity is 1, or this ratio is equal to 1. So we can write PS equal to PK, and K is any point on this directrix for perpendicular distance. This angle is 90 degree. If we find the distance of any point from the straight line, we always find the perpendicular distance. So this distance is PS and this distance is PK. For parabola, PS is equal to PK. Now, PS is the distance between two points. So the distance is x minus a square plus y minus 0 square and root over. Now we have to find the perpendicular distance of point x, y from the directrix. Now if we have straight line ax plus by plus c equal to 0, which is in standard form, and we have to find the perpendicular distance of this straight line from point, say, x1, y1, then the perpendicular distance can be written as mod of ax1 plus by1 plus c divided by a square plus b square. We will use this formula to find the perpendicular distance of point P from the straight line called directrix. So the PK is now 1 into x plus 0 into y plus a mod of this divided by square root of 1 square plus 0 square. Now we will simplify this relation to get the equation for right-sided parabola. So squaring both sides. So this will be x minus a square plus y square. On the right hand side we have x plus a whole square divided by 1. Now expanding this, so we have x square plus a square minus 2ax plus y square. On the right hand side we have x square plus a square plus 2ax. X square are cancelled out. Similarly, a square are cancelled out. So we are left with y square equal to 2ax plus 2ax. So y square is 4ax. This is the equation for a right-sided parabola with principal axis as x-axis or y equal to 0, because this parabola is symmetrical about x-axis. Now, the line joining any 2 points on the parabola is called chord, something like this. This chord is joining any 2 points on this parabola. Now we have a special chord which is passing through the focus, and this chord is perpendicular to the principal axis, and this chord is called latus rectum. Now we can find out the coordinate of endpoints of the latus rectum, that is L and L dash. So x-axis is A and y-axis is unknown. Say this is y1, and L dash should be A comma minus y1. Okay, and L and L dash point are lying on this parabola. It means these 2 points will satisfy this relation or equation of right-sided parabola. So now we can find out y1. So substituting this ay1 in this equation, so we have y1 square equal to 4a and x is a. So this y1 square is 4a square. So y1 is square root of 4a square. It means y1 has two values. One is positive, another is negative. So y1 has to be plus minus 2a. So now we can write the coordinate for this endpoints of latus rectum as a comma 2a, because L point is above the x-axis and L dash point is below the x-axis, so its coordinate has to be a comma minus 2a. And the length of latus rectum is simply distance between L and L dash. So it is 2a minus 2a, which is 4a. And we can also write the equation for this latus rectum, which is x equal to a. Now let's see the left-sided parabola. This is left-sided parabola. Vertex is at origin, that is 0, 0, and distance of focus and vertex is a. So the coordinate of focus is minus a comma 0, and the directrix is at a distance a from the vertex. So the equation of this directrix is x equal to a. In standard form it is 1x plus 0y minus a equal to 0. Any point on this parabola is P, and PM is the PK is the perpendicular distance of point P from the directrix, and this PS is the distance of any point on parabola from focus, and we know that PS by PK is E, which is equal to 1 for parabola, or PS is PK. So distance between 2 points is x plus a square plus y minus 0 square root over, and for perpendicular distance of point P from this directrix is mod of x plus 0y minus a divided by square root of 1 square plus 0 square. Now squaring both sides. So this is x plus a square plus y square. On the right hand side we have x minus a square divided by 1. So x square plus a square plus 2ax plus y square equal to x square plus a square minus 2ax. Now these two terms are cancelled out. Now we have y square equal to minus 2ax minus 2ax. So y square is minus 4ax. So this is the equation for left-sided parabola which is symmetrical about x-axis because its principal axis is x-axis or y equal to 0. Now we have Latus rectum, which is a chord passing through the focus and it is perpendicular to the principal axis. The endpoints are L and L dash. So we can write the coordinates for endpoints of Latus rectum, and it is minus a comma y1, and L dash is minus a comma minus y1, and the endpoints are lying on the left-sided parabola. It means these 2 points will satisfy this equation. So substituting minus a comma y1 in this equation, so we have y1 square equal to minus 4a into minus a. So y1 square is 4a square, or y1 is the square root of 4a square. It means y1 has two values, one is positive, another is negative. So y1 is plus minus 2a. So now we can write the coordinates of L and L dash as minus a comma plus 2a, because L point is lying above the x-axis and L dash is lying below the x-axis, so it is minus a comma minus 2a, and the length of Latus rectum is 2a above x-axis and 2a below x-axis, so length is 4a, and we can write the equation for this Latus rectum as x equal to minus a. Now let's see the upward parabola. Now this is upward parabola. Vertex is at origin, that is 0, 0. Focus is at S, and we know that the distance of focus from the vertex is a. So the coordinate of this focus is 0 comma a. Now we have another line which is called directrix, and the directrix is at a distance a from vertex. This distance is also a. So here the value of y is minus a, which is the equation of this directrix. We can write this equation in the standard form, which is 0x plus 1 into y plus a equal to 0. Now any point on this parabola is denoted by P. You can take anywhere. Suppose this is point P, any point on this parabola x comma y, and the perpendicular distance of this point P from the directrix is pk. So this point is k, which is, this line is making an angle 90 degree from the directrix. pk is the perpendicular distance, and this ps is distance of point P from the focus. So for parabola, PS over PK is E, which is equal to 1. So PS is PK. Now we can find the distance of the 2 points, which is x minus 0 square plus y minus a square. In fact, x minus 0 square plus y minus a square root over, and the perpendicular distance of point P from the directrix is mod of 0x plus 1y plus a divided by 0 square plus 1 square. Now squaring both sides, we have x square plus y minus a whole square. On the right hand side we have y plus a whole square divided by 1. So x square plus y square plus a square minus 2ay equal to y square plus a square plus 2ay. A square are cancelled out. Similarly, y square are also cancelled out. So we are left with x square equal to 2ay plus 2ay. So this is x square equal to 4ay. This is the equation for upward parabola, which is symmetrical about y-axis. So its principal axis, this is the principal axis, which is y-axis, or x equal to 0. Now we have Latus rectum, which is joining the 2 points of parabola, and this line is passing through focus and perpendicular to the principal axis, and the 2 points are L and L dash. So the coordinates of this Latus rectum are x1 comma a, because this x1 is positive because it is lying on the right side of this y-axis, and L dash coordinate is minus x1 comma a, because this L dash is lying on the left hand side of y-axis. Now these 2 points L and L dash are lying on the parabola, so these 2 points will satisfy this equation of parabola. Substituting x1 and a in this equation, we have x1 square equal to 4a, y equal to a. So x1 square is 4a square. So x1 is the square root of 4a square, and square root has 2 values. So x1 has 2 values, which is plus minus 2a. So we can write the coordinates of L and L dash. Here x1 is positive and here x1 is negative. So L is 2a comma a, and L is 2a comma a, and L dash is minus 2a comma a, and the length is always 4a. Length of Latus rectum is 4a, and we can write the equation for this Latus rectum, which is y equal to a. Now let's see the downward parabola. This is downward parabola, and vertex is 0, 0. Focus is at a distance a from vertex. So we can write the coordinate of this focus as 0 comma minus a. Now we have directrix, which is line perpendicular to the principal axis of parabola, and it is at distance a from the vertex. So the equation of this directrix is y equal to a. We can write this equation in the standard form, which is 0x plus 1y minus a equal to 0. Now any point on this parabola is denoted by P, and its coordinate is x comma y. Now this pk is the perpendicular distance of point P from the directrix, and this ps is the distance of point P from the focus. Now for this parabola, we have ps over pk equal to E, which is 1. Eccentricity for parabola is 1. So PS is equal to PK. We can write the distance between these 2 points as x minus 0 square plus y plus a square root over, and perpendicular distance of point xy from the directrix is mod of uh, 0x plus 1y minus a divided by square root of 0 square plus 1 square. Now squaring both sides, so we have x square plus y plus a square equal to y minus a square divided by 1. So x square plus y square plus a square plus 2ay equal to y square plus a square minus 2ay. These two y square are cancelled out. Similarly, a square are also cancelled out. So we are left with x square equal to minus 2ay minus 2ay. So x square is minus 4ay. So this is the equation for downward parabola. Now we have latus rectum, which is the chord passing through focus and perpendicular to the principal axis. This parabola is symmetrical about y-axis, so principal axis is the y-axis or x equal to 0, and these two are the endpoints of latus rectum. So the coordinates of, we can write the coordinates of L and L dash. So here we have x1 comma minus a, L dash is x1 comma minus a. L and L dash points are lying on the parabola, so these 2 points will satisfy this equation of parabola. So substituting x1 comma minus a in this equation, so x1 square equal to minus 4a, y equal to minus a. So x1 square is 4a square. So x1 is square root of 4a square. This x1 has two values, one is positive, another is negative, which is plus minus 2a. So we can write the coordinates of L and L dash as L is 2a comma minus a and L dash is minus 2a comma a, and distance of this L and L dash is length of latus rectum, which is 4a. Now we can write the equation for latus rectum, which is y equal to minus a. Now let's see right-sided parabola whose vertex is at alpha comma beta. It means the vertex is not at 0, 0. Vertex is now shifted to alpha comma beta and it is right-sided parabola. So the equation of parabola is now y minus beta square equal to 4a x minus alpha. It is not y square equal to 4a x. If its vertex is at 0, 0, then its equation has to be y square equal to 4ax. But now the vertex is shifted to alpha comma beta, so y is shifted by b and x is, in fact, x is shifted by alpha. So y minus beta square, y minus beta whole square equal to 4a x minus alpha. This is the equation for right-sided parabola whose vertex is at alpha comma beta. Now its focus is S, and we know that the distance of focus from the vertex is a. So the coordinate of focus has to be alpha plus a comma beta. This is the coordinate of focus, and the directrix is straight line perpendicular to the axis. Here axis is y equal to b. Y equal to, this is the principal axis because it is, this parabola is symmetrical about this line, and this line is y equal to beta. So this is directrix, and we know that the distance of directrix from the focus is again a. So coordinate of this point is alpha minus a comma beta. So we can write the equation for this directrix as x equal to alpha minus beta. And we have latus rectum, which is perpendicular to the principal axis and passing through the focus. The endpoints are L and L dash. So the coordinate, the total distance of L and L dash is 4a. It means from above focus, this distance is SL is 2a and SL dash is also 2a. So we can write the coordinate of this L and L dash as alpha plus a comma beta plus 2a, and L dash is alpha plus a comma beta minus 2a. So this length of latus rectum L dash is again 4a, and the equation of this latus rectum is x equal to alpha plus a. This is left-sided parabola and its vertex is at alpha comma beta. Its vertex is not at origin or 0 0. If its vertex is at 0 0, then its equation has to be y square minus 4ax, but its vertex is now shifted to alpha comma beta. So the equation of this parabola becomes y minus beta square equal to minus 4a x minus alpha. This is the equation for this left-sided parabola. Now focus, this point is S, focus, and we know that the distance of this focus from the vertex is a. So this focus, the coordinate of this focus is alpha minus a comma beta, and we have another line which is called directrix, and the distance of this directrix from the vertex is also a. So this point on the principal axis is alpha plus a comma beta. So the equation of directrix is x equal to alpha plus a. The principal axis is parallel to x axis, and here the value of y is beta. So this is the equation for principal axis, y equal to beta. And we have a latus rectum, which is line passing through focus and perpendicular to the principal axis, and the endpoints of latus rectum are L and L dash. So the coordinate of L is alpha minus a comma beta plus 2a, because this SL is 2a, and this SL dash is also 2a. So the coordinate of L dash is alpha minus a comma beta minus 2a. Length of latus rectum is 4a, and the equation of this latus rectum is x equal to alpha minus a, because it is line parallel to y-axis. Now upward parabola whose vertex is at alpha comma beta. This is the upward parabola with vertex at alpha comma beta. This parabola is symmetrical about a line parallel to y-axis. So the equation for the principal axis is x equal to alpha. And see, if the vertex is at 0 0, then equation of this parabola is x square equal to 4ay. But here vertex is at alpha comma beta. So x is shifted by alpha, y is shifted by beta. So the equation becomes x minus alpha square equal to 4a y minus beta. This is the equation for this upward parabola with vertex at alpha comma beta. Now the focus S, this point is focus, and we know that the distance of focus from the vertex is A. So the coordinate of focus is alpha comma beta plus A, and here we have directrix, and direct distance of directrix from the vertex is also A. So this point on the principal axis is alpha comma beta minus A. So the equation of directrix is y equal to beta minus A. Now we have latus rectum, and the coordinates of endpoints of latus rectum are L and L dash. So the coordinates are, the points are L and L dash, and the coordinates are alpha plus 2A, because this SL distance is 2A, and y-axis is beta plus A, and the coordinates of L dash is alpha minus 2A, because SL dash, this distance is 2A, and y-axis is beta plus A. So the length of latus rectum is L dash is 4A, and we can write the equation for this latus rectum as y equal to beta plus A. Now let's see the downwards parabola whose vertex is at alpha comma beta. This is the parabola, which is downward parabola, whose vertex is at alpha comma beta, and this parabola is symmetrical about this line which is parallel to y-axis. So the equation of principal axis is x equal to A. If it is a downward parabola with vertex 0, 0, then its equation is x square equal to minus 4ay, but now the vertex is shifted to alpha comma beta, so x is shifted by alpha, and y is also shifted by beta. So this is the equation for downwards parabola whose vertex is at alpha comma beta. Now focus is at S, and the distance of focus and vertex is A. So the coordinate of focus is alpha comma beta minus A, and the straight line called directrix is at distance A from the vertex. So this point, coordinate of this point on the principal axis is alpha plus beta, alpha comma beta plus A. So the equation for directrix is y equal to beta plus A. Now we have latus rectum, and the endpoints of latus rectum are L and L dash. Now we can write the coordinates of the points L and L dash. So at point L, x-axis is alpha plus 2A, y-axis is beta minus A, because SL distance is 2A, that's why we have alpha plus 2A, and this distance SL dash is also 2A, so the coordinate of L dash is alpha minus 2A comma beta minus A. Length of latus rectum is 4A, distance between these 2 points is 4A, and the equation of latus rectum is y equal to beta minus A. Now let's solve this example. In this example we have an equation of parabola, and we have to find out the vertex, focus and directrix of this parabola. So this parabola has the term y square. So let's simplify this equation first. This is y square minus 2 into 1 into y plus 8x minus 23. Now we have to convert this into complete square. For that purpose, let us add 1 square and subtract 1 square. Now from the first three terms, we can write as y minus 1 whole square, and this minus 1 square is simply minus 1 plus 8x minus 23. Now we have y minus 1 square equal to minus 8x plus 24. So y minus 1 square. Now let's take minus 8 common. So we are left with x minus 3. Now this one is in the standard form, y minus beta square equal to minus 4a x minus alpha. So the vertex is now 3 comma 1. Now we have to find out the focus and directrix. Let's roughly draw this parabola. This parabola is left-sided parabola. Left-sided parabola, and its vertex is at 3 comma 1. So 1, 2, 3, and on y-axis we have 1. So this point is vertex 3 comma 1, and this parabola is left-sided parabola. It means it goes like this. This is the parabola, and 4a is 8. 4a is 8. It means the value of a is 2. So the distance of focus from the vertex is 2. So this distance is 2. So it means focus has to be at 1 comma 1. This point is the focus, because distance of focus and vertex is 2. And for directrix, the distance of directrix from the vertex is also 2. So this is 1, 2, 3, 4, 5. This distance is 2. So this line, which is perpendicular to the principal axis, and its distance from vertex is 2, is the directrix. So the equation for directrix is x equal to 5, because distance of vertex and directrix is 2. So vertex is at 3 comma 1, focus is at 1 comma 1, and the directrix, equation of directrix is x equal to 1. We can also write the coordinate of this point on directrix as 5 comma 1. Now let's see another example in which we have to find out the vertex, focus and directrix of this parabola. We have the term x square. So let's write x square plus 8x. 8x can be written as 2 into 4 into x. So to make this complete square, let's add 4 square and subtract 4 square. Then we have 12y plus 4. So from the first three terms we can write x plus 4 whole square. Then we have minus 16 plus 12y plus 4. So x plus 4 square plus 12y minus 12 equal to 0. So this is x plus 4 square minus 12y plus 12. So x plus 4 whole square, take minus 12 common, so we are left with y minus 1. Now this equation is in standard form, x minus alpha square plus minus 4a y minus beta. This is downward parabola with vertex alpha comma beta. So we can find the vertex. Vertex is at minus 4 comma 1. This is the vertex. Now let's roughly draw this parabola. This is x-axis, y-axis. Vertex is at minus 4 comma 1. So this point is the vertex. Minus 4 comma 1, and this parabola is downward parabola, so it goes like this. This is a rough diagram. Now we have to find out the focus. So 4a is 12, so a is 3. The distance of vertex and focus has to be 3. Okay, so x-axis is minus 4. On y-axis, we have to make distance 3. So 0, minus 1, minus 2. So minus 4, minus 2 is the focus. This distance is 3. Now for directrix, the distance of directrix from the vertex is also 3. So directrix is line which is perpendicular to the principal axis, and distance is 3. This distance is 3. So x-axis for this coordinate, x-axis is minus 4, and y-axis has to be, y value of y has to be 1 plus 3. So 1 plus 3 is 4. So the coordinate is minus 4 comma 4, and the equation for the directrix is y equal to 4. Now let's see the another example in which we have to find the equation of parabola whose focus is at 2 comma 1 and directrix equation of directrix is 3x plus 2y equal to minus 1. First of all, we need to write this equation of directrix in the standard form, which is 3x plus 2y plus 1 equal to 0. The focus is at 2 comma 1. Any point on the parabola is x comma y. Now we have to write PS equal to PK. PK is the perpendicular distance of point P from this straight line called directrix, and PS is the distance between these 2 points. So for PS we can write here, let's write PS equal to PK. PS is x minus y square, x minus 2 square, y minus 1 square, and square root. It is distance between point P and S. And for PK, we have to write mod of 3x plus 2y plus 1 divided by square root of 3 square plus 2 square. Now squaring both sides, so we have x minus 2 square plus y minus 1 square equal to 3x plus 2y plus 1 square divided by 3 square is 9 plus 4, which is 13. So now let's expand this. X square plus 4 minus 4x plus y square plus 1 minus 2y into 13 equal to 3x plus 2y plus 1 whole square. So this is 3x plus 2y square plus 1 square into 2 into 1 into 3x plus 2y. So we have 13x square plus 4 plus 1 5, 5 into 13 65, 13 4 ja 52x plus 13y square, 13 2 ja 26y, then 9x square plus 4y square plus 3 into 2 into 2 12xy plus 1 plus 6x plus 4y. So 13 minus 9 is 4x square, and then 13 minus 4 is 9y square. Then we have minus 12xy, and then minus 52 minus 6 minus 58x, and then minus 26 minus 4y is minus 30y, and finally 65 minus 1 is plus 64. This is the desired equation of parabola. So that's how we solve the problems of parabola. Thank you.